Okay, so our last type of problem to kind of really explore in depth are these table style problems. So I'm going to do two different types. This one, it doesn't give us the rate. And then the other type of problem, it will give us the rate. So let's go ahead and look at this. So they're giving us time in minutes, and the hot water is dripping through a coffee maker, filling a large cup with coffee, and the amount of coffee in the cup at each time is given in the table. Okay, so if you can imagine, you press the start button at 1 minute, you're going to have 5 ounces, 5.3 ounces in the cup. Okay, so this is not a rate. Okay, and so let's go ahead and start. So use the data in the table to approximate C prime at 3.5. So we're going to go to 3.5, which is in between 3 and 4. Okay, and be sure and write out your work, right? So C prime of 3.5 is approximately equal to C at 4 minus C at 3 over 4 minus 3. Okay, all right, and then so C of 4 is 12.8 and C of 3 is 11.2 and 4 minus 3 is 1. So 8 minus 2 is 6 and 12 minus 11 is 1. So we can do that without a calculator, you guys, don't freak out. All right, and then we showed our computations that led to our answer, and we have to indicate units of measure. So on top, we had the ounces, and on the bottom, we had minutes. So we have ounces per minute. Okay. And I think it's probably a good idea to box your answers just so that they can find them. Okay. All right. Now, is there a time t on 2 to 4, so now we're looking from 2 to 4, which C prime of t is equal to 2, and justify your answer. Okay, so I'm going to now go, instead of from 3 to 4, I'm going to do the same calculation on 2 to 4, because they told us that it's a differentiable function. So what applies if C is differentiable? You said it. I know you did. MVT, right? So if the average rate is 2, we can say there's some time on 2 to 4 that C prime of t has to equal to, and our justification is MVT. You got it. So let's go ahead and calculate that. So we're going to say C prime of t is approximately equal to C of 4 minus C of 2 all over 4 minus 2. Okay, and that's 12.8 again, minus 8.8 over 2, and that sure enough is 4 over 2, which is 2. So we can definitely say yes, there is a time on 2 to 4 where C prime of t is equal to 2, because MVT guarantees it. Guarantees that C prime of 2 has to equal, no, not C prime of 2, C prime of t, sorry, has to equal C of 4 minus C of 2 all over 4 minus 2. All right. Okay. Now use a midpoint sum. So this is interesting. We haven't done a midpoint sum, I don't think, with one of these. Oh, I hope it's still recording. I think it is. I hope it was. Okay. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of this 1 over 6, the integral of 0 to 6. So we're going to go from 0 to 6 is our integral, and we're going to use a midpoint. So then they're telling us 3 subintervals here. So 2 minus 0 is 2, 4 minus 2 is 2, and 6 minus 4. So these were all even intervals, and we're going to use the midpoint. So this number is going to be the height of our rectangles for our Riemann sum. Okay, so here we go. We go 1/6, the integral of 0 to 6 c of t dt is equal to 1/6, and we can say 2 times 5.3. Oh, and we should probably say approximately equal to, right? Because it is an approximation. 2 times 11.2 plus 2 times 13.8. Now, should we spend a lot of time calculating this? No, because we're under time pressure. This is okay, but we need to write our units. What are our units here? So we're anti-deriving, right? Ounces, but then we're dividing by 1/6 too. So this is the average number of ounces. So our units are ounces. Okay. So using correct units, explain the meaning. So this is the average value of C of T, or the average of the hot water amount of hot water in the cup. Oh, ounces. I should say amount of hot water in ounces in the cup. Sorry, because it said using correct units. In ounces in the cup over 0 to 6 minutes. Or during this, you could say during the 6 minutes, for 6 minutes, something like that. Okay. I don't like that. Over, during 0 to 6 minutes. Over is kind of a weird word. Okay. There we go. All right, let's do part D. Let's see what we've got here. Okay, the amount of coffee in the cup in ounces is modeled by, okay, now they're giving us a totally different function. So we're not going to look at the table anymore, probably. Now using this model, find the rate at which the amount of coffee in the cup is changing at t equals 5. So if they give us the amount, to find the rate, what do? You got it, take the derivative, right? So we've got b of t is equal to 16 minus 16e to the negative 0.4t. Okay, so b prime of t is equal to, derivative of 16 goes away, and now the negative 16 goes along for the ride. E to the negative 0.4t stays the same, and then we have to multiply by the chain, which is negative 0.4. Okay, now we've got to find b prime of t at 5. So we're going to do b prime of t at 5. Okay, and if we multiply, we can do this. I'm going to go ahead and do it over here. If you guys are confused at all, we can do this. It's just 4, basically 4 times 16, right, which is 64. And then we've got a point here, so it's point, and the negative goes away. So we've got 6.4 e to the negative 0.4 times 5. So that's 6.4 e to the negative 2, right? 0.4 times 5. 4 times 5 is 20, and then we put in a point there. Oh, can't see that. There we go. And so we could write just 6.4 over e squared if we want. And that should do it. Okay. All right, that is our one example of a table problem.